Welcome everyone to this demonstration of our new QuantumGuard Plus app. Today I'm excited to show you how we're making advanced quantum security and fractal mathematics accessible to a wider audience. This platform bridges the gap between complex theoretical concepts and practical understanding, whether you're a cybersecurity professional, a researcher, or a student interested in next generation security. As you can see on the screen, our app features a clean interface with the progression of topics that build upon each other. Let's walk through each section and see how the app brings these complex concepts to life. So we'll start with the introduction. The app opens up to the fundamental challenges in modern cryptography. As quantum computing advances, conventional encryption methods like RSA and AES face increasingly serious threats. Notice how we've highlighted the key challenges here. Quantum computers can break traditional encryption. Randomness generation often contains hidden patterns, and static security systems cannot adapt to emerging threats. These are the exact problems that QuantumGuard Plus was designed to solve. Let's go to section 2. This is the McGinty equation. At the heart of QuantumGuard Plus is the McGinty equation, or the MEQ. This is where the real innovation begins. What makes this app special is how it breaks down complex equations. Watch what happens when I click on this equation. The app expands to show each component with clear explanations. The McGinty equation combines quantum field theory components with fractal mathematics, creating a framework that's fundamentally different from traditional approaches. The equation has two key parts: the quantum field theory component and the fractal component. This introduces the scale invariant properties. Together, they create a system that's resistant to pattern analysis by both classical and quantum computers. Let's look at section 3. Moving to our third section, we explore how QuantumGuard Plus implements a hybrid cryptographic approach. The key equation here shows how we integrate quantum field theory with fractal mathematics in a practical encryption. When I click on it, you can see how it breaks down the hybrid encryption function into its components. What's important here is that we're not abandoning classical methods entirely. Instead, we're augmenting them with quantum-resistant approaches and our proprietary MEQ enhancements. This ensures backward compatibility while preparing for a post-quantum future. So section 4, in fractal security component. In this section, we dive deeper into the fractal aspect of our security model. The fractal component introduces scale invariant entropy layers through its infinite series. So when expanded, you can see how it creates multiple security levels that require fundamentally different computational approaches to break. This is one of our key differentiators: security that works across different scales and remains effective regardless of the computational power brought against it. The self-similar yet never repeating patterns make pattern recognition attacks virtually impossible. Section 5, RFNU adaptive security. What truly sets QuantumGuard Plus apart is RNA Fisher unity, or RFNU. This is our adaptive security framework. Here we use principles from information theory, specifically the Fisher information metric shown here. This allows the system to quantify how much information is contained in random variables and optimize security parameters dynamically. The result is a security system that can self-organize, self-optimize, and even self-heal when breaches are detected. Instead of static defenses, RFNU creates adaptive security that evolves in response to threats. And section 6 is our layered security architecture. This final section shows how all these elements come together in a comprehensive security stack. Starting from the foundational classic cryptography, we build up through post-quantum methods, fractal enhancements, and then finally the adaptive RFNU layer. This defense in-depth approach illustrates that even if one layer is compromised, the overall system remains secure. Each layer addresses specific vulnerabilities while contributing to the overall security posture. The integration provides backward compatibility with existing infrastructure while also preparing for quantum threats and beyond. So what we've developed here isn't just an educational tool. It's a window really into the future of cybersecurity. As quantum computing continues to advance, approaches like QuantumGuard Plus will become increasingly essential. This educational platform makes these complex concepts accessible without oversimplifying the underlying mathematics and principles. Whether you're a security professional looking to understand post-quantum approaches, a researcher exploring new cryptographic methods, or a student learning about advanced security concepts, this app provides the structured learning path. We're continuing to enhance the platform with additional interactive elements, examples, deeper dives into specific components. And we welcome any feedback or questions as we work to make quantum computing security concepts much more accessible to people. Thanks for your time today, and I'm happy to answer any questions about the McGinty equation or the QuantumGuard Plus platform.